Okay, so quick little bit of info from lesson 5.3, and we're really talking today about the quadrants and in which quadrants are certain trig functions positive or negative. So my little device to remember is that all of the trig functions are positive in quadrant 1. S for sine, sine and cosecant are positive in quadrant 2. Tangent and its reciprocal cotangent are positive in quadrant 3. And cosine and its reciprocal secant are positive in quadrant 4. So, to think about the tangent being negative, well, first of all, you think about negative slopes for tangent. Okay, so you're basically saying, where do you have a slope that's negative? Well, that would be quadrants 2 and 4. So we can kind of rule out quadrants 1 and 3. But we also want the sine values to be negative. And over here, it seems as though, if you kind of take a look, my sine values are going up in the positive direction, whereas in this quadrant, my sine values are negative because they're going down. So I would say quadrant 4. Now, this says, so cosine is positive, tangent is negative. So let's look at our quadrants. Okay, for cosine to be positive, it has to be one of these two quadrants. But for tangent to be negative, we have to rule out quadrant 1. So apparently our triangle is located down here. So I'm going to label my adjacent side 2, my hypotenuse 5. Now, I know that I'm not in the unit circle. If I wanted to be in a unit circle, in that same standard position, I would have to divide everybody by 5. That would get my hypotenuse to be 1. My adjacent side would be 2/5, and then I would need to find my third side. Well, same thing here. So I would do 25 minus 4. So that gives me radical 21. It's negative because it's going downhill into quadrant 4. So when I go to find the sine value, I would have opposite over hypotenuse. So negative radical 21 over 5. All right, let's try this one. My cosecant is negative, which also tells me that my sine would be negative because all I do is take the reciprocal. And I should locate myself then in quadrant 3. Okay, so here it is. So my sine would have opposite 4, hypotenuse 9. The hypotenuse, by the way, will always be positive because it doesn't have left or right, up or down direction. So we have to go with positive for that hypotenuse. Now, this number that's missing, the adjacent side, is necessary for us to find the cotangent. So we'll have to do the Pythagorean. So we will do 81 subtract 16 to get this value. So cotangent is the reciprocal of tangent. Remember SOHCAHTOA. So if tangent is TOA, which is opposite over adjacent, cotangent is going to be adjacent. So negative radical 65, adjacent, over opposite. Negative divided by negative is positive, so you could really just leave it as radical 65 over 4. Okay, a little bit more. Let's just do some reference angles with some nice special right triangles. So I'm going to start with negative 135. So that leaves me with a reference angle of 45 degrees. Now, if you don't know your 45-45 ratios, then you best practice some. Both legs are the same length, and in this quadrant we're going left and down, so they're both going to be negative. Now, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So what I really want to do here is just take the reciprocal of my cosine. Now, this one happens to require rationalizing. Negative 2 radical 2 over 2. And reducing. Negative radical 2. Okay, negative 150. So negative 150 leaves us with a reference angle of 30. You should know that opposite the 30 is the shorter leg. Adjacent to the 30 is the longer leg. So for cotangent, remember tangent is TOA, so cotangent is adjacent over opposite, which is really cosine over sine. So my adjacent side over my opposite side. Now remember, dividing by any fraction is the same thing as multiplying by the reciprocal. All kinds of nice things are going to happen. Negative times negative is positive, and you're going to be left with radical 3. All right, tangent of 390. Now, 390 means once around and then some. So that's going to be reference angle of 30. Again, you should know opposite is the short leg, adjacent is the long leg, and tangent is TOA. So I'm going to have opposite over adjacent. Now, what happened on this problem is going to happen here too. So basically your denominators are going to cancel out. You're going to have 1 over radical 3, which we know will rationalize to radical 3 over 3. Do you still see that this is or one way to think of the short leg over the longer leg? And same thing here. Isn't radical 3 smaller than 3? So try to pick up some ways to help yourself kind of double check your answers. All right, good luck.